Now we introduce a model agnostic method learning. In the regular model learning method, we use a stochastic gradient descent method and a large training data set to train a model, get an optimal parameters of a neural network. This model will cover all the examples. That means we learn all the internal feature of the examples in the training data set. However, after we train the model, we have new examples. We want to, the model cover both previous example in the training data set and the new examples. Here, the new example just have a small number. We don't want to retrain, use the stochastic gradient descent method to retrain all the examples together. We just want to, based on the model we trained, and retrain train the new examples to modify the parameters of the network. That's the idea of the method learning method. This method is a general, regardless of the model. No matter is for classification, regression, and reinforcement learning. The new network, like we mentioned, it uses the training data set to train a model, and the model can cover all the examples. And however, if some parameters of the neural network is sensitive to the change of examples. For example, if we use a new example as input, which is different from all the examples in the previous training data set, then we will have a problem. Now the method learning is, we need to retrain the model using the new example, make sure we get the model to cover previous example and the new examples. That's what we want to do. But be careful, because if parameters of a neural network is not sensitive to the change of examples, then that means even we give one, we use a new example as an input, we still can predict the correct like a class or regression, and other type of output. However, if the parameter of the network is sensitive to the change of the example, then we will have a problem. That's why we need method training, the method learning, just like we just want to use the new example to modify the parameters that are sensitive to the change of examples. For example, here, if this is a model, this is a model, and here is the loss function. If this this new example not sensitive to the parameters, that means there's no loss when we use the new example as an input. So we don't need to change the previous trained model examples, the parameters. But however, if the parameters is sensitive to the new example, then this new example, the loss from the new example will modify the previous trained parameters. So we get the improved parameters. And then the new model consider both the previous training examples and the new examples, so we'll cover both. Let's say we have the model, and we defined loss function for new examples, and then we select the new theta, make sure this theta is, this parameters of the neural network, modified can fit to the new examples. That's the idea. Of course, in a regular model learning, we use, for example, here we use alpha as the hyperparameters. But now we use, for example, use beta for a new example training. Here's a basic this the method description. First, you see, we pick up some examples from the data set. Let's say a small number. This we handle them as new examples, and we use a gradient descent method to calculate their, to calculate the gradient and modify the parameters. And then after we finish the calculator, the whole, we evaluate all the gradient, put it together, we update the model parameters. This, improved parameters can cover the examples in the previous training dataset and the new examples. So in this way, we just based on the trained model, we train the new example and to modify the parameters, make sure the new model can cover both previous example and the new examples. For more details, please check with these references, get the details. Thank you.